All right, velocity time graphs are generally usually a little bit harder for kids to understand because there's especially one thing is a little bit harder to understand. All right, so velocity time graphs, position time graphs tell you your location. Velocity time graphs tell you your movement. Okay, how are you moving? Notice it doesn't necessarily tell you where you are moving, but it just tells you how you're moving. So you don't really know until you get to calculus where you start, but you can figure out how you're moving. So if you have velocity of 0, a value of 0, well, what does 0 velocity mean? That means you are still. So every time you cross the x-axis, you are being still. If you're above the x-axis, you have positive velocity values. So that means you have positive velocity. And what does positive velocity mean? It means you're moving in the positive direction. Below the x-axis, you have negative values. That means you have negative velocity or you're moving in the negative direction. So our little guy again, if he's moving towards the positive numbers, he would have positive velocity right now. But if he was moving towards the negative numbers, he would be under the x-axis. He would have a negative velocity. All right. So first of all, horizontal line. So if I had a horizontal line like right there at a value of 4, that means my velocity was 4. It stayed 4. It was not changing. So that means I have constant velocity. So notice on both position and a velocity graph, when you have a horizontal line, that means you are constant, either constant velocity or constant position, meaning you're staying still. And I remind my kids, constant velocity is like having your speed control on your car. Okay, you're moving at a constant velocity, keeping the same velocity/speed. All right, if you are going up, that means your velocity is changing in the positive direction. So velocity was how your position changed. Acceleration is telling you how your velocity is changing. So if you're going up, that means your velocity is changing in the positive direction. So that means you have positive acceleration. Again, your velocity is changing in the positive direction. It's going up. And acceleration is how your velocity changes, so it's positive acceleration. If it's going down, that means you have negative acceleration. Means your velocity is changing in the negative direction. So we bring in the idea that slope equals your acceleration, just like slope of a position graph gave you your velocity. All right, now, if you're heading towards the x-axis, okay, well, what does the x-axis represent? It represents a velocity of 0. Velocity of 0 means you're staying still. So if you're heading towards the x-axis, that means you are slowing down. You're slowing down. If you're heading away from the x-axis, you're getting away from being still. That means you're speeding up. Now, you've got to look back at velocity and acceleration to know whether you're speeding up or slowing down. So what I do is I get a kid up who I can push around. I have him walk like right now, my little stick man, he's walking, let's say, in the positive direction. If I come up and I'm going to be the acceleration, I'm going to change his velocity. So if he's walking in the right direction, he has a positive velocity. If I push him in that direction, I'm changing his velocity in that direction, what does he do? He's going to speed up because I'm pushing him in the same direction that he's moving. So in that case, his velocity is positive because he's moving to the right. His acceleration is positive because I'm pushing him to the right, and he's going to speed up. But let's say he's moving to the right, but I'm his acceleration. I want to change it into the left direction. Okay, so my acceleration will be negative. I'm trying to change it in the left direction. So he's moving to the right. I grab his hand and I'm pulling to the left. What does that make him do? It makes him slow down until he comes to a stop, and then I'm pulling him this way with me, and he's going to speed up in this direction because I'm pulling him this direction. So it's a little harder to do with stick figures on the iPad. So he's walking to the right, I'm pulling him this way. It's going to make him slow down until he comes to a stop. And then he's going to start moving this direction, and I'm pulling him this direction. He's going to speed up again because we're both in the same direction. Now, let's say, let's just get rid of that. Let's say he is moving towards the left now. So he's walking this way. So his velocity is negative. If I push him in the same direction, he's going to speed up. So velocity negative, acceleration negative, he speeds up. But if he's moving to the left and I grab his arm and pull him this way, his velocity is negative because he's going to the left. But his acceleration, I'm trying to change it in the positive direction. He's going to slow down until he comes to a stop. And then I'm going to pull him this direction. He's going to speed up and go fast again to the right. So that's how I visually, with the kids, I just get a kid up and I push and I pull him where I'm representing the acceleration and he has positive or negative velocity. So if you're going towards the x-axis, you're slowing down, which means your velocity and your acceleration have opposite signs. And if you're going away from the x-axis, that you're speeding up, which means your velocity and your acceleration have the same sign. And so sometimes I do go through an example like here, okay? So it's above the x-axis, so my position, my velocity is positive. It has a positive slope, so that means I have positive acceleration, going away from the x-axis, and so speeding up. So velocity, acceleration are same sign, and going away from the x-axis, speeding up. Then I'll sometimes go down here. Well, you have negative velocity because you're below the x-axis. You have negative slope, so that means you have negative acceleration. Going away from the x-axis, you're speeding up, and velocity, acceleration have the same sign. If it's like this, and this is the one that gets the kids the most. You have positive velocity because you're above the x-axis. You have negative acceleration because your slope is negative. You're heading towards the x-axis, so you're slowing down, and velocity, acceleration have different signs. You're slowing down. This one is hard for them because they forget that velocity is positive there. If it's something like this, you have negative velocity because you're below the x-axis, but positive acceleration because your slope is positive. Heading towards the x-axis, so you're slowing down. And your velocity, acceleration have opposite signs, so again, you're slowing down. Kind of verifies that you're slowing down. Let me delete all that. All right. So if I had something like that wasn't very good. That. Okay. So first of all, I start from being still. Over here I have positive velocity. I'm moving in the positive direction. I'm speeding up because I'm going away from the x-axis. My acceleration is positive. Velocity, acceleration have the same sign, speeding up. Here I have a horizontal line, so I have constant positive velocity because I'm above the x-axis. So I have my cruise control on, going like 2 meters per second constantly. Doesn't mean I'm still. I'm moving at 2 meters per second constantly. Also, my acceleration is 0. Slope of a horizontal line equals 0. I probably should have put that over here. Acceleration equals 0. All right. Along this next little segment, I still have positive velocity because I'm above the x-axis. So I'm still moving in the positive direction, but my acceleration is negative because my slope is negative. I'm slowing down because I'm going towards the x-axis until I become right here and I'm still. Okay? So moving in the positive direction, I have positive velocity, but I'm slowing down until I get to 0. So a lot of times kids will want to say, you're moving in the negative direction because it's going down. Nope, I'm moving in the positive direction because I'm still above the x-axis, but I'm slowing down as I'm moving in the positive direction. Right here, I'm still, and then I have negative velocity because I'm below the x-axis. I'm moving in the negative direction. I have negative acceleration because my slope is negative. I'm speeding up because I'm going away from the x-axis, and my velocity acceleration have the same sign, and that means I'm moving in the negative direction. Another misconception sometimes people have is right here. I am still, but my acceleration is still negative. If my acceleration was 0, I would be staying still. I wouldn't be moving because my velocity wouldn't be changing. But I'm still along a negative sloped line, so my acceleration is moving in the negative direction. So if I was going to do that with this little guy, and let me pretend, so here he is, okay, and these are positive position, that's towards the negative position. So again, I don't know where he started. He could have started at the origin, he could have started at a negative position, he could have started at a positive position. I don't know because it's a velocity graph. But what I do know is he started off being still, and then he started moving in the positive direction with positive velocity, positive acceleration. He's speeding up, and then he's moving at a constant velocity in the positive direction, so he's got his speed control on. And then he keeps on moving in the positive direction, but he's going to slow down until he becomes still, and then he's going to start moving in the negative direction and speeding up, going in the negative direction.